Hi, my name is Anna Wojtowicz and I'm a member of the NiCE development team at Oak Ridge National Lab. The last couple of months I've devoted a lot of time to improving integration for moose-based products in NiCE. This includes Bison, Marmot, Relapse 7, and Raven, so I just want to take this opportunity to show you a little bit of what I've been working on this summer. The first module in NiCE is called our Moose Model Builder, and it's intended for defining a problem and generating input files. We offer two methods of getting started with this utility. You can construct an input file from scratch, or you can actually import an already existing input file to modify. For the purpose of this video, we'll just go ahead and import a file I prepared ahead of time, thanks to the magic of internet television. Once the data is loaded up, first thing we need to do is specify which Moose application we're tailoring our input file for. In this example, we'll choose Bison from the drop-down menu, and now we should have a complete structure of Bison-specific blocks available to us here in the tree view. As we expand each node, we can see any subblocks specified in the input file have also been loaded, and any pertinent parameter data will be displayed in what we call the Properties view. It's here in the Properties view we can also edit our parameters. Of course, we can also add more blocks to our structure by selecting a parent node, clicking the green Add Child button, and specifying which subblock we'd like to add. From here, we can fill in any parameter data or rename the new subblock as well. Similarly, blocks can be deleted by highlighting them and clicking the red X button at the top. Lastly, for the special case of hard path blocks with types, like the executioner block, the Properties view contains a drop-down menu which will allow you to easily toggle between the different types. As you do this, you'll notice the set of executioner and type parameters actually merge and change to reflect the currently set type. Now, you might be wondering what's going on in this big empty space here on the right-hand side. This is real estate we've set aside for a 3D Bison mesh editor that we're currently working on, although it isn't quite ready for production yet. So in the future, you can expect to be seeing 3D meshes of rod structures in this spot. Once we're done constructing our input data, check off any blocks that you'd like to be written to the file. Any blocks not selected will be omitted from the final product. We specify the file name here at the top, save our work by clicking on the floppy disk button, and then select the Write Moose File process action and click Go. The input file will be generated in your default NiCE workspace. If you want, you can double check your work by opening and reviewing the file before we go on to the next step. The second part of our Moose integration into NiCE is called the Moose Launcher, and it's designed for specifying any input files pertinent to our problem and executing the actual simulation either on a local or remote machine. We first must specify once again which Moose-based product we're working with and immediately apply our selection by saving our workbench. Doing so will allow us to specify any additional input files that are needed for the particular problem. In this case, Bison is requiring us to also specify mesh, power history, and peaking factor files, which we've placed in our default NiCE workspace ahead of time. Here on the right, we can also utilize parallel execution at this point if we choose to. And lastly, specify the machine you'd like to push the job to. We save our work one last time, select the Launch the Job process action, and click Go. Your simulation will now begin executing on your destination machine. Depending on your system's configuration, you might also be prompted for credentials at this point. I hope you've enjoyed learning a little bit of what we've been working on this summer at Oak Ridge National Lab. If you have any questions or comments, you can contact us. Our contact information will be at the end of this video. And I just want to say thanks for watching.